In this video, I'm going to talk about the DateTime struct, or the DateTime functionality that you can use in C Sharp. And so just a brief reminder of what a struct is. So it's similar to a class, but you'll find that it has less functionality. And it is a value data type instead of a reference data type. And so these are kind of the, I guess, two big important things to keep in mind about Struct, at least at this point in our journey about coding. But the struct can contain parameterized constructors, static constructors, so on and so forth. It can be used to hold small data values that do not require inheritance. And so inheritance is something that classes can do, and I will talk about that here in a couple of videos actually. And so it can hold things like coordinate points, key value pairs, complex data structure, and so on. And again, it cannot inherit another structure or class, and it cannot be the base of a class. So those are things that I'll get into when I start talking more about object-oriented programming. But in this video, I will be talking about the DateTime struct. So DateTime is a struct that you can use in C Sharp that allows you to sort of measure time and so forth. But some things to know about it before we get into that. So it's a value type. It represents dates and times with values ranging from midnight of January 1, year 1 CE through 11:59 p.m. December 31, year 9999 CE in the Gregorian calendar. And so the time values are measured in 100 nanosecond units called ticks. These ticks are not terribly accurate, but they're small enough that over time they kind of average out any error that occurs in them, and so it allows a very accurate measure of time. But yeah, they are in 100 nanosecond units called ticks, and so they are pretty small units of time. So a particular date is the number of ticks since midnight of January 1, year 1 CE in the Gregorian calendar class calendar. So the number excludes ticks that would be added by leap seconds. For example, a tick's value, so this would be a tick's value represents, so this many ticks will have passed between January 1, year 1 midnight and Friday, January 1, year 100 at midnight. And so a date time value is always expressed in the context of an explicit or default calendar, which will be the Gregorian calendar for this. All right, so the way you can actually use this, so we have date time, date equals new date time, so we instantiate an object from the date time struct. Then you can use date time min value, and so that will give you the 1 year 1 midnight. Max value gives you the maximum value of the date time. So you can use .date to give you this will give you the minimum date and time, and day gives you the minimum date and gives you the minimum date rather. So it's the 1st of January. So day of week gives you the day of the week, which would be Monday for that minimum value. Day of year gives you the minimum day of the year, and so that would be the 1. The time of day gives you the day for the minimum date and time, and so that is midnight here. And so the year gives you the minimum year, and so that's year 1. And so we can use these dot now dot and dot today to give the current date and time. And so the output of this will depend on when the code is actually run, because it'll give you the current time and the current day or date, which will also depend on when the code is run. But another thing you can do is this time span here, which allows you to get a time span here. So this would be days, hours, minutes, and seconds. And so we make this duration 1, then we do dir1 added. So date dot add, so duration 1. So this adds 36 days to the minimum. Where if we do this, now we're doing hours, minutes, seconds. So this adds 14 hours, 23 minutes, 11 seconds. And so that's adding that onto the minimum. And then you can do add days like this, and that adds 101 days to the minimum. But now let's take a look at some of this in a little more concretely. So I just have the code written up here with it all commented out. So I'll just uncomment this as we go. So I'll uncomment this. And so this is looking at the date. So well, I instantiated DateTime as an object called date here. So I'll be using date for this, and then .date will give us this output. This day will give us this output. So these will be all the minimum outputs right here. So if I run this code, we get this. And so yeah, we see that this prints out this minimum date. It gives us the minimum date here, which is the first so it's the first because it's the 1st of January. It says that Monday is that day. It's the year, or the first here. It's midnight and it's year 1. And so that's what this code here will print out. And as usual, this code will be in the lecture notes, which will be linked to in the description down below. So if you want to look at it in a little bit more detail, you can find it there. All right, so well, I will uncomment out this this next part here. So we're using the min value and max value, which will give us this minimum value we've been seeing and the maximum value of December 31, year 9,999 at just a second before midnight. But then we're also looking at now, today, and UTC now, which gives us the sort of Greenwich Mean Time for now. And so when I run this code, you will see that the date that I'm actually and time that I'm actually recording this on, and you'll probably notice that it's several months in advance of when this video comes out. So I've been recording just a bunch of these coding videos recently, and well, to be perfectly frank, the reason for that is because I'm actually just learning this stuff right now. So I'm learning this as I'm sort of as I'm making it, and making these videos is what I'm doing to study for my final that I'm going to take here in a couple days. And so that's why I'm kind of doing these videos. Just a little bit on how the sausage is made, I guess. So anyway, I'll run this code, and this is what I get. So we see we get the minimum value and maximum value here, and then the now and today right here. So we see that it's April 22, 2023 at 9:18 a.m. when I am recording this. And we see this for the UTC time right here. So this would be 4:22 at 1:18 p.m. Right here. So I am like 4 hours behind that. But anyway, so that is what this code does with the now, today, and UTC now right here. All right, and so then I will uncomment this out. So this gives us these time span things here, just like I did in the original presentation. So we have 36 days in this first one, then we have 14 hours, 23 minutes, 11 seconds in the second one, and then this one here is 101 days, and that will add that onto those minimum values. And so when I run this code, it gives me this. So 36 days added. So this is after 30, this is 36 days added to that minimum time right here. So we see that that is February 6th, year one at midnight here. Then if I add 14 hours, 23 minutes, 11 seconds, we see that it's the still January 1, year one, but now we have these this 14 hours, 23 minutes, and 11 seconds added. With 101 days added, we see that this brings it to April 12 of the year one right here. And so that's what we can do by adding these durations. So we can do time span, duration equals new time span, and then we put these parameters in here for that. And it goes by day, number of days, number of hours, number of minutes, number of seconds on there. All right, so then if I uncomment out this, so we see that we can actually sort of parameterize this date time here with dates and times. So we have the year, so this would be 2015, the month, so that would be December, the day, so the 31st, the hour, 5 hours, 10 minutes, and 20 seconds. Then down here, we just do the same thing, but we change it to the date time kind of UTC, so UTC time zone. So when I run this code, so this is the set time. So we see that it's December 31, 2015 at 5:10:20 a.m. Then for this at the UTC, we're setting this to the UTC right here. And so that is what you can do, but by sort of parameterizing your object here, your date time object right there. And so now what I'm going to do is probably actually one of the more useful things we can do with these date time codes here. So I'm going to uncomment that out. And I'm actually just going to recomment this out so that it's not taking up too much of the processing, because what we're going to notice here is that we're going to be measuring how long it takes for this to actually process things. And so in the first instance here, we are sort of measuring the time it takes to do a 1 million iteration loop here. So a 1 million iteration for loop here. And so what we see is that above here we have date time dt1 equals datetime dot now. Then below that we have datetime dt2 equals datetime dot now. And so dt1 will be the time before we start the for loop, and then the dt2 will be the time after we start the for loop. So this value and this goal is just the number of iterations. But the thing to notice here is we can do an arithmetical operation on these times here, and it will actually give us the difference in time between it. So this dt2 is our final time, so we put that first, and then the dt1 is our first time, so we put that second. And this will take the first time minus the second time minus the first time, and it will give us the span of time between that. And so that will tell us how long it actually takes to do this 1 million iteration for loop. And so when I run that, we see, so goal is just the number of iterations we did, which was 1 million. And so we see that this is the time it took. And so this is sort of in the, like millisecond time right here. So it didn't take that long to do 1 million iterations. But Now, if we uncomment this out, so this is a nested for loop. And so now instead of a million iterations, we're doing 10,000 multiplied by 10,000, which is 100 million. And so you can see, even though each of these loops has considerably fewer iterations than this single one up here, we end up with many more iterations that it actually has to go through. And so this is sort of how you can measure the fact that that this is like a quadratic time here. This is a polynomial time rather here when we start nesting these for loops. And that's why you sort of want to avoid nested for loops. And so when I run this code here, we see that the first one, we're still, you know, quite low on time here. Then this one is in order of magnitude more time that it took to actually run that code. And so I think you can guess what sort of comes next, and that's a triple nested for loop. And this time it's only 1,000 iterations in each level of this nest. So it's 1,000 multiplied by 1,000 multiplied by 1,000. So that ends up being a billion. And so again, we have less or fewer iterations in each one of these. I guess I should uncomment that out too. So we have fewer iterations in each loop, but because we are nesting them, we will end up with many more. So we see that this is even taking a few seconds. So this is taking 2 seconds to run this, where these ones are taking less than a single second to actually run them. And so again, that's just sort of an illustration of the fact that these nested for loops end up being polynomial time to actually run these. And so that's why if you can, you usually want to avoid using nested for loops. And so then in this code down here, so this is just looking at the fact that we can do this measurement by using the dot seconds, dot milliseconds, and dot ticks here to actually look at the number of just seconds, just milliseconds, and just ticks for this. So if I run this code, we end up with this. And so we see that again, it took a couple seconds for that to run. And so seconds from the triple loop. So when we print out just the seconds, it's 2 seconds. So that's what we had there. The milliseconds was 340. So that's what we had right there. Then the ticks for the triple loop. So remember, a tick is 100 nanoseconds. So that's how many 100 nanoseconds. So if you multiply this by 100, it'd be that many nanoseconds for the triple for loop. So these are all for that triple for loop. So yeah, those are some of the things that you can do with the date time struct, as well as the as we saw up here, the time span struct here. And so, yeah, this right here, at least in my limited experience, is probably some of the more useful stuff that you can use the date time stuff for, is sort of measuring the time it takes for code to run. But anyway, I hope you found this video helpful, and I will see you in the next one.